sketching curve. So we're talking about, again, PDF, CDF, so the probability density function and the cumulative density function. This time we're talking about normal curve. This has a couple of different names. Bell curve, because of the shape. Gaussian, because it was developed by Carl Friedrich Gauss. But anyway, the two parameters for this are mu and sigma. This is the mean and standard deviation of the particular normal curve in question. But these two parameters are needed for determining it. And so how do they affect the shape of the curve? Okay, so first the PDF graph. So the bell curve has a shape like this. This hump here is controlled, is going to be at the mean. So mu controls where this hump is. And if you change mu, make it larger or smaller, it's going to shift where this max value is. So it shifts where the peak is. Okay, what about sigma? Well, what sigma does is, so you have your bell curve, and then if you have a smaller standard deviation, it narrows this curve, and so you have a larger spike here. So smaller sigma drives that peak up, makes it narrow. So it's tall and narrow. If you have a larger sigma, it's going to broaden it out, and so it flattens the curve and makes it wider. Okay, so the effect of the changing the mean is it shifts where the peak is. Changing the standard deviation is going to make the peak either narrow and skinny, or it's going to make it flat and broad, so it's wider. Okay, what does the CDF look like? So again, what does the CDF first of all tell you? Oh, also, hold up, before we do that, this has tails here. So it has, there is possibility of seeing values far away from the mean, but it's small and it's two-tailed. So it never shuts off, but it gets very small. So for practical purposes, it does turn off, but there is still a chance of seeing values far from the mean. They're just very unlikely. Okay, so the CDF graph. So because this is symmetric, the mean is going to be half, and then it's also going to, so this value here, which corresponds to the peak of the mean, this is going to be half on the CDF graph. Remember, the CDF graph is telling you the chance of seeing an observation smaller than that particular x value. So you have some value here, and it tells you the area under this curve here. So it's the entire area under the curve. That's because the PDF function tells you the entire area under the curve for everything small x less than or equal to x, and that's the cumulative probability of all seeing any observation less than or equal to x. This value here is 1. So again, it ranges from 0 to 1, and it's got this smooth curve up.